We're going to be looking at the following circuit diagram. We can assume the op-amp is ideal and has power input rails at 20 volts and also a negative 20 volts. In our answers, we need to report the magnitude as positive, and the angle has to be between negative 180 degrees and 0 degrees. This is going to come important when we get to this later. So let's get started. With this problem, we can see that we have some V negative right here, and we're going to be using Kirchhoff's voltage law. We have some V positive right here, right? And now, knowing that we have Vn and Vp, we can see that this R2 right here is going to act as an open circuit because it's being connected to the ground. Current flows this way, so this has no effect on it right here. So Vp is equal to 0, and we know by op-amp rules, Vp is equal to Vn. So we can write out our method for this, and then we're going to have Vn minus the V inputs, and this is all happening over the resistance in plus the capacitance in. Now we need to convert this capacitance in to the S domain, so it's going to be Zc equal to 1 over S times C. So we're going to have Rin plus 1 over S times C, and then we're going to have a plus V, and then we are going to have N minus the V out, and this is all happening over the RF resistor, and this is all going to be set equal to 0. So this is going to be the equation we're working with. Now we know that Vn is equal to Vp, and we know Vp is equal to 0, so we can say that these are all 0. Now we're going to move V out over to the other side. We are going to get that our V out is going to be equal to, we can also multiply both sides by RF, and then we're going to have a negative V input times our RF, and then we are going to have this being divided by our Rn plus 1 over S times C. Now, there's a few things that we can do from here. The first is that we're just going to box this up, because this is going to be kind of our general equation. But we do actually, instead of boxing this up, we should convert this using the J omega is equal to S. So coming down here, we're going to say that our V naught is equal to a negative. We have our V input being multiplied by our RF. And then in the bottom, we have the Rin plus. Now this is the part that's different. We're going to have 1 divided by the J omega times C. And that's super important to note, because we are introducing omega down here and also in here. So we're going to solve for part A first, where our omega is 0. And when omega is 0, like this, we're going to have this capacitor be some big number, right? Because it's microfarads, which means we're going to have we're going to have a big number over a small number. And essentially, when our omega is equal to 0 rads per second, this is going to be going to infinity. And if this goes to infinity, no matter what we have on top, because it is constant, we have our Vn right here, and we have our RF. So we have some constant over infinity, and we know that some constant over infinity is approximately, we can just say 0, right? So in here, for our answer, we are going to have 0 for our magnitude. Now, the angle is going to be a little bit different, because we have this 0 right here, and we're dealing with this capacitor, and capacitor is at a default 90-degree angle, inductors at 90. We're going to have an angle of 90 or negative 90 degrees inside of here. So we're going to have 0 and negative 90 degrees. Now we can look at the next one with the 200 rads per second, and so that'll be, we'll just do this like this, and we can plug our 200 rads into here. So we're going to say that our V naught is equal to a negative, we have our Vn times the RF divided by the Rin plus 1 over J, and this is going to be I when we plug into a calculator for imaginary number, times 200 times our capacitance, which is 0.05 times 10 to the negative 6 for the micro. Now plugging this into a calculator, I'm going to use Symbol Lab for this. And using Symbol Lab, I'm going to get this answer right here. So we're going to have all this be equal to the 5 over 13 plus 25 over 13. And note that to find magnitude, we are going to have the square root of our real number squared plus the imaginary number squared. And then the angle is tangent -1 of our imaginary number divided by our real number. And so from here, we're going to get a negative 1.96. And actually, this negative should be outside. It doesn't matter though, because when we have it in polar form, the angle being multiplied in does not affect our angle. It only affects the magnitude. And then we have an angle of 78 point, approximately, let's just say 69 degrees. Now, we want our angle to be between the 180 or negative 180 and 0 right here, right? So what we're going to have to do, we'll draw this out, and we want it to be on this side of the graph, right? Currently, it's like right here. So what we're going to do is, well, since it's a negative 180, we're going to subtract 180 from it. So we're going to have an angle minus 180 degrees. And so we're going to get negative 1.96 with an angle of negative 101.31. And since it also says that in our values that the magnitude is positive, it says it right here, we're going to have to make this magnitude a positive by just making it a positive. And so our answer here is going to be 1.96 at an angle of negative 101.31 degrees. So that's the answer for that part. Now we can look at C. The only difference with C is that we're going to be replacing this value with 1000. I'm also going to plug this into Symbol Lab, just like this, and we are going to get 5 plus 5i. So that is going to be the complex or rectangular form for this problem, and then we could just put it in right here for this gray part. Also going to move this up just so we have more space. So this is going to be for the gray, which is for part C. And from here, we can just plug our values into the polar form, and then we're going to get approximately 7.07 at an angle of negative 135 degrees. Remember to subtract the negative 180 because it has to be down here. And then we're going to do the same thing where we plug in the, instead of 200 or 1000, we're going to plug in 5000 for the last one right here. And so plugging in 5000, and then, you know, we're going to get the polar form, or sorry, we're going to get the rectangular form, which is this. We're going to get the rectangular form, and then we're going to change it into the polar form, which is up here. Have to subtract 180 from the angle, and then make the magnitude a positive, and we're going to get 9.8 at an angle of negative 168.69 degrees, and that's in volts. And so that is how we would look at this problem.